sense? Okay, sweet. Let's try this again. So, all right, so let's get into data modeling, right? The fundamental unit of modeling for us is going to be an object. And an object will typically be some kind of like real-world thing. It is a single meaningful whole that is composed of a number of attributes or properties. And so, for example, in our introduction, we talked about, well, there's this person. The person is an object, and that person will have attributes that depend on your application's needs. And the examples that I'm going to work with here might include like age, height, weight, and so forth. Objects are typically represented in table-like diagrams, so you'll have some table, it'll have a title, and then it'll be the attribute listings underneath that. You can almost think of these as like JavaScript objects. It's surprisingly similar. Yeah, I have a collection of properties, and so a person might look kind of like this. So first name, last name, sex, weight, and height are all the data points about a person that I want to store. And then my application will probably have many people in it. So. Objects may not always represent really concrete physical things such as people. Sometimes they'll represent more abstract concepts like a shopping cart in Amazon. It's like, okay, yeah, we have a shopping cart, we put stuff in it, but it doesn't actually physically exist anywhere, right? Another example that's slightly abstract is an address. Like, how do you model an address? Well, probably the same way most people do it everywhere in the United States. If you look on any form anywhere, which is a good example of like needing to model information, like what's important to get from a person, usually you have two placeholders for street and then city, state, and zip, right? In every case, though, even though we have these individual points that I'm calling attributes or properties, the object itself is the whole, is like the meaningful whole of that. Yeah. And this will make sense when we talk about how databases implement our sort of theoretical, more formal models. They work from wholes. So inside of each of these objects, we have attributes. Attributes should have two properties. They should be simple, and they should have an identifiable type. Okay, so what do I mean by that? So a simple data point is a single piece of information, as opposed to, say, these objects, which are lots of pieces of information. So an address is not an attribute because it has street number, city, state, zip, and so on. But the city is an attribute. The state is an attribute. First name is an attribute. First name isn't composed of pieces. It's one meaningful single unit. But a person has lots of different pieces, and so we don't want to confuse those, right? Again, we'll have attributes and objects. When we're modeling, we want to identify the types of our objects, the types of our attributes. And this is very much like types in programming. We need to know if our attributes strings, right? If they're numbers, if they're Boolean, if they're date, what? And typically it'll be a simple type for a simple data point, right? When they're numbers, we want to be aware if they're integers or whole numbers, or if they're real numbers, or like floating point numbers or numbers with decimal places. Databases typically store those differently. If you tell a database to use an integer and you try to put 52.5 in it, it's going to store 52 or 53, or maybe give you an error. So we have to make that distinction for in terms of the underlying implementation, at least for SQL databases. So we can modify our diagram to indicate the type of the data points for our person, or the type of the attributes, right? So now we have a person object. Our person object has these attributes, and these attributes are this type. So the first name is of type text. Last name is of type text. Sex is of type integer. Weight is a real number. Height is a real number, and so on. What may not be obvious is that the type itself may not be obvious. Like, why would you choose one type over another? So here, like, I'm using integer for sex. Why would I use an integer? So, well, maybe because in my application knows when it sees a 0 for sex, and when it sees a 1 for sex, that means female, or vice versa, right? Or maybe I make it a text instead, and when I see M, that means male, and when I see F, that means female. And I ask here, like, which one of these makes more sense? Would you rather use numbers or text for sex?
Text.
Text? How come?
It's more logical.
Descriptive.
More logical, maybe more descriptive?
But if you use a number, it takes up less space.
Takes up less space, sure. What else?
I was going to say number because it takes up less space.
Okay, so again, so that's like the less space. Anything else? Why else would you use numbers or text? Yeah.
Text, you might have some problems with crossing this. Some might be capped, some might not.
So I think it's like more likely that you'll introduce errors if you're using text. In some databases, you can specify the possible values for a field. I think that's right, Mayo? And do you know in SQL, you can say it's either has to be a capital M or a capital F or like a 0, 1, or 2.
Okay, you said it, that property.
Set it, but you might, if there's an error in your application code or it's input that a user is providing, they might provide a value that's not quite what you're looking for. I saw other hands.
But it's not, I mean, could you not program it such that it's already typed out and the user just clicks it?
Generally, that's what you would do, right? But it might be that you've made a bug and not the user, yeah? And so at some point in your application, you let a lowercase m slip in. I think there's a balance here. Descriptivity, or being descriptive, is a really valuable asset anytime you're working with programming. When it comes down to it, probably using a number is easier because it will be easier to program and maybe less prone to mistakes. And then you can also very easily do Boolean switches when you know you're only dealing with a binary variable, a 0 or 1. And so it's almost like I would say, if not female, then that means it must be male, and that might be easier to program. Yeah?
I was going to say, like, along the lines of, descriptivity, I felt actually like running our shop was like clarity over brevity.
Yeah.
So like, yeah, a 1 and a 0 would be like easy to store, less space, but like, so when it looks in the database, is like,
what does that mean?
You can
Yeah.
assign it.
Yeah. Generally, being more descriptive will stave off something called technical debt, where your application becomes so complex because of shortcuts that you've taken that saved you time now that it becomes difficult to make changes to in the future. So technical debt, it's like you're borrowing against your future productivity. And I would say generally probably descriptivity is the better route as well. Although here I think I would still lean towards an integer. I think that's one of the advantages of using a SQL type system over a MongoDB is you can actually specify what values in a database, and if you try to put in the wrong one, if you try to put in the wrong one, it raises an error. So if like you made a programming error, the database will tell you you have a programming error and you can fix it. So, but point there is that type is not always obvious. You really have to think about this. I think another good example here is what if when we're modeling the address, we have a zip code. What type makes sense for a zip code? Initially, you might think, well, a number, because a zip code is a number, 73069 or 73001 or whatever, 90210, right, Beverly Hills. But when you think about it, zip codes are really used more like text or more like a string of digits. And then a properly or completely formed zip code is not actually a number. So it's actually more something like this, 73069-1234. And that is not a number. You cannot put that in a database when the field says this must be a number. You'll lose that trailing bit of information. And so you really have to think through the possible data is going to be used and how it's going to be represented and make sure that you're getting those details right. As always, it's okay to make mistakes up front. So I'm a firm believer in try something and see what works, and when it doesn't work, then just change it instead of it has to be this way, and because that's the specifications. Yeah. So we've got objects, we've got attributes. Does that distinction make sense? I don't think it's too difficult, although you'd be surprised. Sometimes you can sort of get confused about an object not being an attribute. You think, oh, well, that's a simple thing. Well, actually, no. You need to break it down into pieces, and it needs to be its own object. So typically, when we're dealing with objects like this, they're going to be inside of collections. A collection is just a group of objects of the same type. So it'll be like all the people together, or all the addresses together, or all of the medical records together, or whatever, right? It's common for applications to deal with collections and not just single objects. That's very typical. Very rarely do you have an application with one person in it, or one address in it, or one anything, right? Typically, we have a multiplicity of objects. And so, for example, a medical application tracks more than one person, and a clothing application will probably have many customers. So, collections are nothing special. They're kind of like lists or arrays in JavaScript, so we've actually already dealt with collections, but with an important difference. Usually, an object is not allowed to occur more than once in a collection. So collections are distinct, or they're composed of distinct objects. In mathematics, that makes them a set. And all of SQL database theory, so SQL database theory is really set theory underneath, and for that reason, yeah, it deals with distinct objects. So what does that mean? What happens if I need to put two people in my database, and I identify them by their name, so first name and last name? Well, turns out there's another Philip Dow over there. He does these crazy acrylic sculptures, which I think is awesome. So if you can, I mean, so it's nuts, right? So if both of us signed up for the same service, and I'm tracking people by name in my database, we have the exact same name. So according to my collection of objects, there are two things in there that are not distinct. So when that person signs up, is it going to clobber my record in the data, my fields, or what's it going to do? Really, we're two distinct people. So how do we keep track of that? Typically, an item inside of a collection or an item in a database will be marked by some kind of unique identifier that is guaranteed to match only a single item. And you might think, okay, that can just be first name and last name or social security. Yeah, okay, why are you tracking people's social securities when you are a clothing store application, right? What you'll do instead, this is a really common practice, is you will add a field or an attribute to your object called the ID. And it's a numeric value which uniquely identifies every entry in your database. And so if I show up as, me, Philip Dow, my ID might be 54, and if this other guy shows up as Philip Dow, his ID might be 122. And then operations that you perform on the objects in your database, you identify always by these unique IDs. And so this should ring a bell when we're working on our blogging paths, or we're working on our post paths or our comments paths. Notice how I always abbreviate that one parameter ID. That represents the ID of the object in the database. And that is how we will get to that object in the database. When we ask for the complete list of objects, we are guaranteed to get the ID back with them, and then we can build our URLs out of those IDs so that when a person clicks on one of them and requests that specific item, I can pull it out of the URL and then use that parameter, that ID parameter, to identify the database, right? And that's a very common practice. And it turns out, both in SQL systems and I think also in MongoDB, the database will automatically generate these numbers for us. So we don't have to generate them ourselves. MongoDB objects use a object ID that it will automatically create and is guaranteed to be unique across not only one computer but many computers, so that if you spread your database across multiple computers, you'll never have two objects that have the same identifier, which is a pretty neat feature. It's a hex, so a string. Whereas in MySQL, you'll auto-increment an integer, is what that's called. And every time you add a new item to the database, you don't provide the ID. SQL generates the ID for you and gives it back to you. And then from that point, that's your reference for that object, your key for that object, right? And so if we were modifying our person model, we would include the fact that there is an ID, which is some kind of unique integer or unique identifier, right? I think that's pretty straightforward. So objects, attributes, and collections of objects. Not too crazy, right? It gets more interesting and definitely trickier. Sorry, I'm losing my shoe. When we deal with relationships. Relationships are definitely where things are get a little more complex. I don't know what I'm doing here. Objects in a database will be related to one another. Modeling, so the process of modeling, of identifying objects and their features, also includes identifying the relationships between objects in your model. Modeling includes that, right? Includes the notion of relationships. And a relationship isn't just between two different objects, like a person has an address, and those are two separate objects, but somehow we need to relate them to one another. Modeling includes the cardinality of the relationship, which is a property that says how many of a thing can this be related to. And we're going to talk about the different kinds of relationships, their different cardinalities here in a second. But for example, in an online clothing application, excuse me, for which we have a person model object, the customer, let's say, the customer also has an address. And so I'll have in my database some way of storing customers, right? And then I identify all the attributes. And then I also have some way of storing addresses, right? And I identify all those attributes. And I need to note the fact that a customer can have an address, and we typically draw an arrow from one item to that relationship. The customer will also have a shopping cart, right? And so if we're building a shopping application, I have this shopping cart thing. It has some attributes as well. We could say that its attributes are maybe date created, last modified, any discounts currently being applied. And I'll see that my customer has a shopping cart. But then inside of each shopping cart are a number of products. So I also need to have some kind of products object in my database that includes things like the name, the category, the price, and maybe date added, things like that. And so my shopping cart will refer to the number of products that are in it. So that when I want to see what products a customer currently has in their shopping cart, I need to get that customer from the database, get their shopping cart from the database, and then get the products that are in that shopping cart from the database, right? And so it's really subtle how quickly a database can balloon into a lot of objects and a lot of relationships between those objects. You think, oh yeah, you can just build a shopping application, right? And it gets complex surprisingly quickly. Most databases do. And the reason for that is not because of objects and their attributes. You can pretty much figure those out. The reason is identifying these relationships to one another. And as we'll see, there are different kinds of relationships. So a customer might only have one address. So you might write in your database the fact that a customer can only have one address. But what if a customer says, hey, wait a minute, I want to ship it to a different address, but I want to keep my original address in the database. So I want to ship it to my parents' house, but don't erase my address. Right now, your database allows that to happen. You have to create something called a to-many relationship that you sort of indicate with two arrows here that says one customer can have many addresses. So, and then maybe you might only have one shopping cart, but if you're Amazon, you've got wish lists, right? And your wish list has a number of attributes. And a customer can have more than one wish list. And each wish list makes reference to a number of products. And both of these are what are called to-many relationships, which we'll discuss here in a second, because a wish list can have many items in it, just like a shopping cart can have many items in it, right? So this stuff gets a little hairier once you start thinking about the relationships. And it's good to have some of this thought of in advance, but always, again, be okay with changing these things around. So this is called a graph, or the relationship graph, I think is the best way to think about it. If you're familiar with graph theory in mathematics, you have nodes and vertices have directions. That's all this is. Object is a node. You connect those nodes as relationships, and they go in a certain direction. Relationships between objects, like I said, for the cardinality, that's typically one of three kinds. So you'll have relationships that are one-to-one, one-to-many, and many-to-many. And no matter what kind of database system that you're using, even though, say, in MongoDB that's not really explicitly modeled, it's still good to think about your objects like this, because that's really how things work, even maybe in the real world. Yeah? Do I have one father, or do I have many fathers? That seems like a really straightforward question, right? I have one father. I'm adopted. So I have a birth father, and I have my adopted father, who I actually call my father. So do I really have two fathers? Is that actually a one-to-one relationship, one child, one father? What about the other direction? So if you're a father, do you only have one child, or do you have many children? Or do you have one wife, or do you have many wives? And maybe some of them are not currently married to you or not, right? Thinking about that stuff gets subtle. That's what I mean by this cardinality, or this one-to-one, one-to-many, and many-to-many. So I'm going to give you some examples of this to make that concrete, and then we're going to get practice with this as well. So, a one-to-one relationship between two objects, we'll just call them A and B, says that a model object of type A has one single relationship to a model object of type B. So you take one object of type A and one object of type B and relate them to one another, and that's it. A cannot know about more than one B, and B cannot know about more than one A. If you pick an A, it knows about one B. And again, that's a little abstract, but in our example shopping application, a customer has a single shopping cart. That is a one-to-one relationship. Entire collection of customers. So you have 100,000 people using your application. One of those customers logs in. So you pick out one customer out of your collection. And that customer wants to get their shopping cart. You look at that entire collection of shopping carts, and you can find the one single shopping cart that belongs to that customer. That is a one-to-one relationship. Or vice versa. If you start with the shopping cart, and you pick out of all of your shopping carts one shopping cart, and say, who does this shopping cart belong to? You will only ever find one customer, right? Customers don't share their shopping carts, and one customer will only ever have one shopping cart. So that is a one-to-one relationship, right? I think that's the most straightforward one. They're often called has one or belongs to, because you can say a customer has one shopping cart, or one shopping cart belongs to a customer. And so you hear that. Depending on which way you direct that model, so I could say that my customer, as I wrote it here, has a shopping cart, and I could model that from my customer, and we'll learn about that in a second, but it'll mean like I have some kind of shopping cart ID on my customer that points to the unique ID for this shopping cart. Or I could do it in the other direction. I could say that a shopping cart belongs to a customer. So my customer doesn't actually know anything about the shopping cart. Instead, my shopping cart will have a customer ID attribute. And I use that to uniquely identify which customer it belongs to. And depending on your application's needs, it'll make sense for you to do it one of these ways or the other. Yeah? Typically, you don't do it both ways in case you have to update things. And according to a concept called normalization, which we might touch on a little bit. I think one-to-one is pretty straightforward. Does that make sense? Okay. I think more the difficulty is figuring out which kind of relationship you're dealing with, because it's surprisingly not always obvious. Sorry, I'm kind of losing my voice a little bit. I talk too much. You can tell me that. A one-to-many relationship between two objects A and B in a model says that if I pick out of all of my A objects a single one, and then I look at all of my B objects, I might find multiple B objects that are related to that A. I won't ever find one single B object. I could find 5 or 10 or 100, right? But from one A. However, if I try to go the other direction, if I pick out any one item from my B objects, I will still only ever find a single A that it belongs to. It is one from A to many B's, one-to-many relationship. And again, to give this a sort of concrete example, consider Amazon's wish list. A single customer can have many wish lists. That is a true fact on Amazon. You can create more than one wish list. Usually you have a primary one, but you can add more. So in the collection of all customers, if I pick out a single customer, the customer who's logged in right now, and I go and try to find their wish list, I will get multiple wish lists back. And somehow I need to allow the customer to choose which wish list they want to look at. Which wish list they want to look at, right? On the other hand, if I'm starting from wish lists, and from the entire collection of wish lists that I have, I pick out a single wish list, and I say, which customer does this belong to? I am guaranteed to only ever get one customer back, right? I have, again, a one-to-many relationship. So that's another fundamental type of relationship when you're thinking about data models. And I think one-to-many is probably the most common type that you'll deal with. A parent can have many children. A child can have many parents, a mother and a father, for example. A customer wants to order many products. A bookstore has many books, right? But a bookstore, a book in that bookstore cannot be in two bookstores at the same time, right? It's from the bookstore to the books, one too many, but not the other way. There is finally this other type of relationship that is probably the most fascinating one. I think it's pretty cool. And the most powerful one of the group, I think, too, as well, is the many-to-many relationship. So you now have a collection of types of objects A and B, right? And you'll pick one object out of that A collection. And you'll go, which B objects are you related to? And you'll get a lot of B objects back. And then if you go on the other direction and pick out a B object from that collection of entire things, and you go, which A object are you related to, it will give you many A objects back. And this is called a many-to-many relationship. And I think a good example for it is a tagging system for files on your computer. So imagine that you've got files on your computer, just any kind of document like a normal file on your computer that has some attributes such as the name, the path, when you last opened it, when you created it, and so on. But then you also have tags. And a tag, like a word that you give to something, computer science or OK Coders or politics or whatever. And you can create as many of these labels as you want. And according to your specifications, a file can have many labels, so the same file can have more than one label. But anytime that you use a label, one unique label, you can use it on more than one file. So I have many documents that I consider political, and one of those documents, political is not its only tag. It might also be economics and foreign affairs, right? So one document has many tags, and one tag has many documents. That's a many-to-many relationship. And I think these are particularly powerful, and I think it's a real disappointment that we don't see this implemented more often. I think maybe it's a little more difficult. Imagine if you could have a file on your computer exist in more than one folder at the same time. So right now, the relationship between folders and files is a one-to-many relationship. Take any folder out of your entire hard drive, and it contains one file, or many files, excuse me. But now take any file on your hard drive, and it really only ever exists in one folder. You have a one-to-many relationship. Yeah, you can have symbolic links and stuff. I think I see you smiling over there. So there's ways to, like, actual in the underlying implementation, a thing was abstracted from its physical representation in the real world and became more of a conceptual, like, interrelationships of stuff. Yeah, I think that's pretty cool. I think it's cool because a product that I built a long time ago worked that way. So. Model your relationships. Okay, so we have objects. We have the attributes that belong to those objects, or the features, rather. Let's say that. Our objects will exist in collections, so we're going to have lots of the same type of object, not typically just one. And then between our objects, there will be relationships. You have to explicitly model your relationships just as you model your objects. That is part of the model, right? As well as identifying whether it's a one-to-one, a one-to-many, or a many-to-many. So ultimately, how a model exists, or like what format it takes, will depend on the database being used. Either way, you should be thinking about this, right? This is important to understanding your product, and it might also offer you insight on how like things in the real world kind of work and why structures are set up the way that they are. So,
just a question, just with this.
Yes, I'm going to get some water, but ask away.
With your products, then you would have to model, for example, the stock room, to make sure that they're stock, and then would you have a model from that?
So let's think about that. So how could you model a stock room? What if you didn't want to create a stock room object? How would you do that instead?
Make an attribute on the product that's like a quantity.
Yeah, I like that. I think that one's a little bit better. So I could have a attribute on product like in stock, which is a Boolean value, or you could have a quantity, not just quantity, but like quantity in stock, right? And that would tell you that it is in stock. Yeah. I mean, I suppose you could have a stockroom object that referenced many properties, particularly if you had to manage many different stockrooms as part of your like enterprise. Mm-hmm. So those are, those are both, I think, valid ways of considering that.
So that in stock would be its own property, though.
Would be its own property on the products.
So would we need a separate?
I think it depends on the needs of your application, and especially more so the needs of the people who are using your application.
Because that product is really what's in the shopping cart of the customer, and there's a direct relationship.
Right. Okay. So that's a good point, right? So we actually, in a sense, products exist over here completely independently of the shopping cart, right? So it's like it doesn't really matter. Products, shopping cart. There's this relationship that kind of crosses a divide. And when we talk about something like quantity, are we talking about the quantity of product in stock, or are we talking about the quantity of products that the person has put in their shopping cart? Right? That's a subtle question that could lead to very nasty bugs in your application. Typically, what you will have is some kind of intervening object here that relates, especially in a many-to-many relationship, right? Because you can have a shopping cart can contain many items, but a single particular item itself might not exist in more than one shopping cart, but that object, not one, but like just that book, might be in more than one shopping cart at a time. More than one person on Amazon are shopping for, O'Reilly's new data science book or whatever, and at the same time exists in multiple shopping carts. So how do you represent that fact? You have a table in the middle where you've got the shopping cart ID, the product ID, so we'll call this the SID, and then the product ID, and then additional information like quantity ordered. Right? You'll have a middle object that just models a relationship between the two objects. Yeah, and that's where it gets really abstract. Yeah, you've got an extra object that is explicitly like self-referential, it's referring to your model, and that would be a way that you would do that. Right? Because that's a totally good question and it's pretty subtle. There's probably more than one way to do this. I see sort of my own.
I was just passing that out of that.
Yeah,
it makes sense.
Yeah, there's definitely other ways to do it. I think it would be definitely different in Mongo. This is how you would do it in a SQL system for sure. You'd have a table in between. So, but that's a really good question. And I think that's the trick. Like, we're getting a very fast introduction to modeling. This is a super subtle issue. I mean, people spend a whole 2 semesters studying databases in a computer science degree. And some of that is more highly theoretical, but a lot of it is understanding this stuff, right?
So is that like a temp table, or is that like, it's actually a table where you're storing a lot of them? Yeah,
you'd probably actually have a table where you're storing a whole bunch of these, right? And that's the thing too, like we're talking, this is a nice pretty picture on a board. How many customers do you have? 500,000. How many products do you have? 2 million. How many products might currently exist in somebody's shopping cart? 150,000, right? So like we're hiding a very complex underlying bunch of data here with just the formal relationships and attributes of those objects in the model. But yes, I think this will be an actual real thing. It's a sort of a layer of abstraction on top of the actual things that you're modeling. And that's why I say model your relationships. This is modeling your relationships. Yeah. But again, there's lots of different ways to do this. And there's not necessarily a right way. So this is not like, here's how you do it every single time. There might be some best practices, but usually it will depend on, the user. And then possibly what kind of database system you're using, and also what kind of application layer you're using as well. So you'll have conditions that kind of constrain your ability to do some of these things. Okay, I want to keep moving. Talk about SQL-style databases for a little bit, and then there's a section on MongoDB, and then I wrap it up with some CRUD. So there's not too much more here. So again, a data model is a formal representation of data in a system. Objects, attributes, and relationships. That's what we're identifying. But the actual data, ultimately, that we need to like store in our database, or stored, will be stored in a database. Like I said, we're going to use MongoDB in this class, but MySQL or SQL-style systems, or so the structured query language style systems, are used very widely. I think is helpful to understanding a Mongo type system or document-based database. So, SQL-style databases, such as SQL Server, MySQL, MariaDB, SQLite, Postgres, and so on, store objects in tables. So the actual sort of thing that it's stored are called tables. A table includes a schema, which identifies model attributes and their types. That's called the schema. It's like the formal definition of the table. And then the table itself is composed of rows and columns. And so this is very much like an Excel spreadsheet. Take an Excel spreadsheet, give yourself a column header like this, where you identify the attribute and then its type. And then in rows down that table, each one of these is an object in the database with these values for those attributes, right? It's really nothing crazier than an Excel spreadsheet with some more complex mathematics underlying it to make it efficient, right? But this is what it will look like. So we could have a SQL table with 3 entries for our person model. So I say, this is my person table. Here's its schema right here, which is the exact same thing that we saw above. And then I've got 3 items in it. Notice I have unique identifiers for each of them, and then first name, last name, sex, weight, and height, right? And then in SQL, in the structured query language, there's actually a syntax for asking the database for information from it based on these attributes. So we can select, we can project, we can do all kinds of crazy things. We can join tables together and stuff that gets pretty wild, and really powerful as well. Relationships in a SQL database are typically supported with what are called foreign keys, and we kind of hinted at this up here. But in a one-to-one relationship, one of the objects will include in its model some kind of foreign ID attribute that refers to the ID attribute of an object in the other table. And so let's say, I do it with customers down here. Let's say I have the address table. Yeah. What do we know my address has? My address has a street number 1, or street 1, street 2, city, state, and zip. But then I also might add another attribute to it. 1, an ID attribute, because I want it to have some unique identifier. But 2, a person ID. And then the value of that person ID in a table column will be a 1 or 2 or 3 to refer to that person. And then that's how I know that they're related to one another. I establish relationships using these unique identifiers. That's how I make the relationship explicit, make it known. And then again, SQL provides facilities for automatically connecting these things together when I ask for information from the database. That's called a join. We're not going to learn about that in this class, but it's astonishingly powerful. So, the example I give more explicitly, in our shopping application, we've got 2 tables, customers and shopping cart, right? So I've got a customer table and a shopping cart table. And the customer table might have a shopping cart attribute ID for a particular customer, and it will be the ID of a particular shopping cart, or in the other direction, because it's a one-to-one. And that's how I've done it here. So I've got these customers, 3 customers, and then you'll see in my shopping cart, I have this customer ID attribute, which they call a foreign key, and it has a value that corresponds to one of my customers. And so this says that Johnny Johnson here has a shopping cart that he last modified on March 18th, 2014. Yeah? And this 3 to 3 is the relationship between the 2 of them. So that's how I know that this shopping cart belongs to this person. If I started from my customer, I can't get to the shopping cart. I actually have to ask the shopping cart for the customer with whatever ID I'm dealing with. Yeah. So again, which way you go, which direction, depends on the needs of your application. So if I allowed a person to have more than 1 shopping cart, so let's pretend for a second that I could save a shopping cart for later and then create a new one, okay? Kind of like wish lists. Then nothing would really change. Yeah, we'd still have this shopping cart table, like an Excel document. We would still have rows and we'd still have columns. But now, because it's a one-to-many relationship, notice that my customer ID repeats itself. So one customer, customer number 3, can have 2 shopping carts instead of 1 shopping cart. And that's how you would model a one-to-one and a one-to-many relationship in a SQL database. So if you ever encounter that, good to know. Again, we're going over this because I think it illustrates some of the theoretical stuff pretty nicely. So, and again, Johnny Johnson has 2 shopping carts, so he created a second one. It's got a different discount and so on. So, and we kind of hinted at this here. In the many-to-many model, usually you'll have a separate table to hold foreign keys to the 2 tables for the objects that are related. That's this thing. That's this in-between table between my my shopping cart and the products that it contains. And in that table, I really only have IDs. So I have a unique identifier 1. This is referring to file ID 1 with tag ID 2. This is in the files tags, right? So how can one file have many tags? And how can one tag belong to many files? So the tag whose ID is 2 is on 1 and 3, those 2 files. And then this file with ID1 has tags 2 and 4. So this allows me to model a many-to-many relationship. There's no way that we could do that like this, without repeating ourselves inside of the original table, which is a bad juju. So, and then what you would do, I think, if we were doing with our shopping cart, you can imagine that this is actually the shopping cart ID. This is actually the product ID. And then we would have another column here for quantity. And then that would store, again, the quantity of items of that type in that particular shopping cart. But again, that goes in this separate table, and it's actually its own table, or you can imagine it's a separate Excel file. So, and there are some application frameworks. I don't know if Node does it for us. Certainly not Node itself. One of the ORMs might do it for us, one of the SQL ORMs. But in Ruby on Rails, yeah, you keep track of this stuff. You don't have to do it explicitly. Ruby on Rails does it for you. Active Record, which is their object relational model, the thing that gets database information into objects inside of your application, automatically handles all that stuff for you underneath the hood. And you use a special syntax inside of the programming language that says many-to-many relationship with these keys. You like write one line of code, and it handles all the database stuff for you. So, because this stuff is nasty, it gets pretty hairy. If you look at the Wikipedia model relationships, I think you'll see a good example of like crazy, right? Like that stuff gets insane. So, and maybe that's not exactly right, but there are database ones that will look so insane. So, nice to have an application layer do that for you automatically. So, or your framework do that for you automatically.
Your second example, there was a difference between unique integer and foreign key.
Mm-hmm. Where's that?
In your second example, so that you have
what are we looking at here?
It's here.
Okay, customer shopping cart. Okay.
Unique, under the shopping cart column. Yeah. So you have one with a unique integer, which refers to you.
This guy here?
Yep.
No. This is the unique integer for the shopping cart entry, right?
Oh, I see.
Every entry in the shopping cart table will have its own unique ID.
I see.
And these are different, right? Because this is the unique ID for a customer, and this is the unique ID for a shopping cart item, right? So, a good question. And then 3 is what refers to that guy there. And that is more explicit when you actually see it done in the database rather than on a diagram like this. So importantly for SQL databases, and a big distinction that we're going to see when we're using MongoDB, one, the values in a particular column for a particular row. So let's go up here. So if I'm looking at my shopping cart, and I look at my shopping cart item 1, and I look at last modified date, that value must be a simple data type. One single simple data type, such as a number, a string, a date, or whatever. And dates ultimately are represented as numbers, but it's a simple data type. And then importantly, the column itself cannot contain another table or a collection of data points. So I cannot take a shopping cart and have a list of dates in it, or an array of dates, or an embedded table that also contains information about files, tags, or whatever. Yeah. If I want to refer to another table, I need to do it by its unique ID. That's the only way I can do it. SQL imposes those restrictions on us. Yeah. So simple data types and no embedded data types, no arrays, no objects, no references to, no explicit other tables actually in it. MongoDB, we'll see, does not impose that limitation on us. We can do everything in MongoDB the same way that we do it in SQL, where we create different tables for all of our objects and then stick objects in those tables. They're called collections and documents instead of tables and rows. But MongoDB also allows us more flexibility in that our values at particular columns for particular items can contain nested data information. So we could actually have arrays of objects or contain entire other tables inside of a table. And it gets pretty crazy. So we'll do that real quick, and then we're going to wrap this up, and take a break, and then do some more group work. So in MongoDB, this document-style database that we're going to be using, and there are others like CouchDB, all part of a movement known as NoSQL or Not Only SQL that stores data a little bit doesn't use the structured query language. In MongoDB, and tables and rows. So instead of thinking of things in terms of an Excel spreadsheet, we have collections and documents. But there's kind of a one-to-one correspondence here. Collections are like tables, and documents are like rows, right? But first, a collection does not require that you define the form of your data in advance. So this is very different. If you've used SQL before, you have to have a schema. You have to define your schema. When you create your table, you give it a schema, or the form of the data, the attributes that that table will contain. And you cannot break that. If you try to add a new item to your database and it has an additional attribute, SQL will freak out on you and throw an error. And you can't do that. MongoDB does not care. You do not have to define the format in advance. You can just start sticking data inside of a collection, and if you change the format of that data, you can just change it and stick more data in there, and MongoDB doesn't care, right? We're going to see why that works in a second, because it's not organized like a table, like an Excel spreadsheet. And people really like that, although it means that you're moving some of the organization of your data to the application code. Previously was doing some work for you. Now you have to do that work explicitly in your application. So if you added a new attribute 1 year into your application going public, you are guaranteed that not every item in that collection will have that attribute. So when you pull items from your collection somewhere in your code, now you need to check to see if the item has that attribute or not. You've just added an additional layer of checking to your application. On the other hand, it means that you can make changes very quickly and sort of like prototype a product very fast, which a lot of people really like. So, so let's see what. Oh, and then second, a collection supports nested data points in it itself. It can actually contain other objects or lists of objects. And we're going to see why that's possible in just a second. So I think this is awesome. Sorry. And what that means, and Google went and freaked out on me again, is now recording me. I know. I don't know why it's recording me instead of my screen. Happened before. Anyway. So what that means is that we can actually implement our relationships differently in MongoDB than we do in SQL. We can still do it the SQL way, except for we don't get joins, or we can do it a more uniquely MongoDB way. And I'm going to show you that difference here right now. So let's take our person object, and let's see what it looks like inside of a MongoDB. Let's actually look at a collection of people. So above here, I had this guy for people, right? Right here. And it looks like an Excel spreadsheet. In MongoDB, it's actually a JavaScript array that contains objects. Actually, a JavaScript array that contains JavaScript objects. Underneath the hood, MongoDB uses a binary representation of this information, but our access to it is done in JavaScript. Like if you just log into your MongoDB, you don't write SQL, you write JavaScript, and you get back JavaScript objects. Which is pretty wild. This is why people are really leaning more towards like what's called full stack JavaScript development. We write JavaScript for our client-side application, stuff that runs in the web browser. We write JavaScript for our server-side application, like Node, and we write JavaScript to query our database. And so that's called full stack JavaScript. All three layers of our application, essentially the model, the view, and the controller, all use JavaScript, which is pretty neat. But anyway. This is the same information that I have in that other table, but organized like an array of JavaScript objects. This is just another way of representing that information, right? So I have an ID, first name, last name, and joined. An ID, a first name, last name, and joined. But notice the table columns, which were these guys right here, get repeated for each item in this array. That is why it is possible to change the format of your data midway into your application. If I add a new object here called password, right? Or sorry, a new attribute here called password, and I insert a new object in my array, it will now have ID, first name, last name, joined, and password. The object kind of carries its attributes with it, right? Whereas in SQL, the table identifies the attributes, and a row just knows that it has a bunch of data. But it's the table that knows what kind of data is allowed. Here, the object itself, thanks to these named properties, is actually carrying that information around with it. And when it gets returned to my application, I can introspect that. I can look at that object and go, tell me what property, and then do something different depending on the result, right? So is that difference clear? This is not rows and columns. This is an array of JavaScript objects. So, and just like in JavaScript, we can have nested data. And that means that the way that we model relationships changes pretty radically. So like I've already said, I'll say it one more time. We can do it the way we do it in SQL. We have lots of collections, and each collection has a bunch of objects in it. Or we can start to embed some of these objects inside the attributes in another object. And we know how to do that. Hold on a sec. We know how to do that because that's just JavaScript. We already know that an array can have objects, and then an object can itself have other arrays of objects, or an object can just have another object, yeah? And that looks like this. So imagine I've got my customers and shopping carts. I could have a whole nother array of objects for my shopping cart. That's some other collection, right? This is my customer collection. I could have a shopping carts collection. And the shopping cart has IDs for themselves and then information about, you know, who it belongs to and product. And somewhere in here, I could have a shopping cart ID that refers to that shopping cart. That would be how SQL does it. But in MongoDB, I can just embed the shopping cart inside my customer object, right? So I can just say, hey, give me a shopping cart attribute on this customer. And that shopping cart itself has a last modified and discount attributes. And if I wanted to refer to products, I could have a products here and make it an array. I could make it an array of objects that include a product ID and the quantity. And I can do all of that inside one single collection, or if you're thinking in terms of SQL, inside of one single table, which is not possible in SQL. Yeah, we cannot embed data like this in SQL, but we can do it in MongoDB. And that means we will always have a choice. Do we want to set up our data to be stored more like SQL, or do we want it to be set up more in this like embedded data document format? Yeah? Pinned on the needs of your application and what you have to do with that data. There is not a right or wrong way. It depends on what you're doing with the information. In some cases, it will make a hell of a lot more sense to keep this information separate. In other cases, it makes a hell of a lot more sense just to embed it right in there. Yeah. I mean, look how, this is a bit easier. Look how easy it is to check if a person has a shopping cart. Give me the person. Is there a shopping cart attribute? No, then they don't have a shopping cart. Not join shopping carts with person on ID shopping cart foreign key with person ID with this like crazy SQL syntax. If you've ever seen SQL, it gets nuts. And then now see if I got a result back for shopping carts for that person. A little hairier. So it's pretty neat, right? And that's what I'm just pointing out here. This third item in this customer collection includes an embedded shopping cart. Can't do that in SQL, right? So, and that would be a one-to-one relationship. But I could manage a one-to-many relationship the same way, right? So now Johnny Johnson has more than one shopping cart. It's still a shopping cart attribute, but it's an array of objects of each shopping cart. So this thing right here is equivalent to these two guys right here for Johnny Johnson, right? Only now I'm doing it with JavaScript arrays and objects. And that's what actually gets stored inside of MongoDB. And this would be a one-to-many relationship. A many-to-many relationship, on the other hand, might require separate collections for each type of object. So I might actually, if I have, let's say, tags and files, it might be harder for me to embed tags inside of files. It might be better for me to have files separately. How would I model that then? Like, how would I establish the relationship? What could I do? Let's not worry about answering that. I'll leave that to think. Just sort of think about how would you do a many-to-many relationship inside of Mongo. Yeah, you had a question a while ago too.
So just to think about Mongo is multi-dimensional array of JavaScript that is called multiplayer inside
I mean, in a sense, really you still only have one dimension in this array, right? It's just that you have objects in the array. But if you consider attributes of objects a dimension, then yeah, in a sense you have multi-dimensional objects. Yeah, that's right. Yeah. So we got hypercubes here, baby. So again, there's not a single right way to do this. There's not a single right way to do it in SQL. Talk to different people, and they'll be like, do it this way. But there are certain ways that make it simpler. Really, it's more a matter of thinking about this and having to think about this every time you build a product. What kind of data do your customers need to deal with? What kind of attributes should that data have? How is that data related to each other? And what is the easiest way for you to store that data so that your customers can manipulate it and you don't have to write a lot of code? That's part of the process of building an application. And so I know a lot of the time we've spent most of our effort like actually trying to make stuff and learning how to make stuff. This is more of the problem-solving thinking aspect of it, right? Something you have to consider every time. So. Last paragraph. What do we do with data? Ultimately, no matter what kind of data we have, really we do 4 things to data. We create it, we retrieve it so that we can show it, we update it in case the user wants to change it, and we delete it when they want to get rid of it. And that is called CRUD, C-R-U-D, create, retrieve, update, and delete. So if data modeling is identifying the underlying data, and database lets us store that, the database itself will typically support at least 4 kinds of operations, almost certainly more than 4 types of operations. All databases, all file storage systems, any way of storing data anywhere must let you create, retrieve, update, and delete it at a minimum. Yeah. If you can only create data but you can't delete it, then you're the NSA. If you can only delete data but you can't create it, then you're other parts of the government. I don't know. Joke, joke, joke. So. But typically, these are the things that we need, right? We'll see, again, that both SQL and document-based languages like MongoDB let us do all 4 of these things. But importantly, that these line up to HTTP operations very nicely. So we saw when we were creating resources for like a blog post or for comments, we really need to do 4 things to those blog posts. We need to view a whole list of them. So that's the show, and that's a kind of retrieval. We need to view a single one of them. That's another kind of retrieval, but for a particular item. We need to create them. We use post for that, right? So if you remember looking at those resources, when we want to show items, we use the GET request. When we want to create an item, we use a post request. When we want to update an item, a particular item, we use a put request. And when we want to delete or destroy an item, we use a delete request. So the 4 HTTP verbs that we've kind of already used explicitly line up, not by accident, by design, with the 4 kinds of things that we need to do to data in our database. So that when we design web-based applications, we want to set it up so that the thing a person is doing with URLs matches the expected result that we'll be taking with the database by way of our application's code. And then we get all 3 layers of this thing that we kind of introduced in the last class, model view controller, where our database has got our model. Our node application is kind of this mediating controller from the database to the views, which is the HTML that our person is browsing. And then backwards, when they're posting things to our application or getting things from our application, those are the actions that they take through the views, and our application mediates that to the database, so on. And I mean, HTTP is for building distributed applications, and applications need to do CRUD. So that was part of its design from the beginning. This stuff was all hypothesized in like the 60s and 70s. It's been around for an age. So. Okay. So that's like an hour of sort of more theoretical type material. Any questions about this stuff? Whew. Right? So let's take a break. Let's take 5. So feel free to get up, move around. We're not in a rush today. There's nothing else that I need to do. I know, crazy, right? We're going to practice this. And we're going to practice it in groups, but let's take a break. So.
Oh, really? Okay. So you're good. Okay, I was like, did you do it? It's mine. So it's like, what's going on?
It might not.
So it works. What was the thing? My H. What's that? I remember my website. Face. My face.
I made the API server. Cool.
Especially after I forgot to email you.
So it could be run. It's running somewhere. Is that on like DigitalOcean or Roku or
Roku.
Roku? Yeah. Cool. I'm down. Let's point him at it. Let's get him practicing with modules and all kinds of stuff. We'll end up standing. You know, each person will stand their own MongoDB server through Heroku's whatever Mongo service. I'm gonna have to figure out how to do that because I've used Postgres on Heroku before, but I haven't used Mongo explicitly.
They actually go through Mongo Lab.
Mongo Lab, yeah,
So
right.
they actually just go directly through.
And then you set up some keys, yeah, right, and it knows to. So there's some config that has to get done.
They'll give you a connection string.
Yeah, okay, so that's not
And
too
you just take
crazy.
a connection string and drop it in your app.
Really?
That's it.
What about like username and password or?
It's in the connection string.
Okay, so cool. Well, that's easy.
No, man, you know.
So we're gonna learn next week. You want to talk about MongoDB?
We're talking about it right now.
It's not water.
It looks like you're doing programming. When you're like, where the?
Zach said that he likes to replace him. He just left it.
Yeah, it's actually, I mean, like, it's actually.
I hate you guys so much. We love jalapeno. Not cool.
Oh. I don't know. Start a website. That can be stored in a Mongo database.
No problem.
They're gonna be like, we're all our shit.
Come on. Somebody like
I'm not really bad.
No, that's it.
Yes.
Yeah, my cousin started Java.
Actually, they go all of them. All of them. Definitely.
I'm just afraid to say that.
Yeah, over.
Yeah.
Okay. You can take your food with you, so feel free to keep eating. We're going to do some group work, and I don't mind if you guys snack while we're doing that.
You gotta hurry up and eat them. You're not disrupting.
You're gonna need some blank paper. If you've got blank paper, I'm sure we can find some. If you don't, there's blank paper over by the printer. Let's hope they don't mind me giving away their paper. Might need a writing utensil. Or you need to be working with somebody who's got a writing utensil. All right, so what we're going to do, we're going to practice modeling. So I think as an exercise to make sure that we kind of have our heads around how this sort of works, right? So get a sense for what kind of stuff we have to think about and just how subtle it can be when we want to model a system or you know, a process or a set of objects that people can manipulate in our application. What are we going to model? The typical thing to model in this kind of exercise is like a shopping cart type, system. You build a shopping project and you have to figure out the model for that. That's a very common exercise that you see in a lot of programming textbooks. Ultimately, we're going to be modeling how to build a blog in this application, right? But that's stuff that you should be doing for your homework and thinking about for your homework, so that's not what we're going to do in class. Instead, I've decided that we're going to model Airbnb. How many of you guys are familiar with Airbnb? Who is totally not familiar with Airbnb? Is it a book? No.
Bookstore. I mean,
nope.
That sounds.
Airbnb, this is good because when you're starting to model something, you may not have any idea about what it is, particularly if you're working with clients. Airbnb is a service that lets individuals rent their houses and apartments to other people. And so they've crowdsourced like apartment renting, but it's not I'm going to rent you my apartment because I'm a landlord. It's I live here. This is my apartment, but I'm going to be gone for a week. So if you want to stay in my apartment for a week while I'm gone and pay me $800 or $200, then fantastic, you can do that. Airbnb facilitates that kind of economic interaction. Okay, and so you can imagine what the requirements for an application like Airbnb are. Say I'm a person who has an apartment. I need to be able to sign into Airbnb and list my apartment. I might actually be a landlord, so maybe I do have more than one apartment, and so I might need to be able to list more than one apartment. And what kind of things do I need to associate with that listing? Dates of availability, maybe add a couple of pictures, the price, its location, where is it, right? So there's a lot of information that needs to be associated with a rental unit type thing. Then, on the flip side of that, I'm a person who's going to visit, San Francisco for a week. I need a place to stay. All the hotels are booked. All the hostels are booked. Maybe somebody has an apartment that they're going to be out of for that, that period, and I want to stay in their apartment, and they're cool with that. So I hop on Airbnb. I search San Francisco and find out that there's like 10 people who all have their apartment available over that period. And so then I can, view those items, see how much they cost. See what's available, what the locations are, and then maybe get in contact with those people over email and negotiate an okay, stay, right? And so those are kind of the requirements of an Airbnb style application. And it's in a nutshell. So this, like, where do I want to go? I want to go to San Francisco. Who doesn't want to? Amazing. I want to check in, hopefully, when she's not there. Let's say the 23rd, and then to the 31st, I'm gonna, number of guests. So these are all things that they have to keep track of, right? How many bedrooms? I'll search for it. And yep, look at these are all the listings in San Francisco available. Let's see, I used to live in North Beach myself, so let's get a place in North Beach. Look at all these in North Beach. I used to live right on Columbia at Union, right over there. I used to live like right there, like literally like right there. So I want to get a place that was just up the street. Ooh, that looks nice. Penthouse with a panorama view on Russia Hill. Okay, so then maybe I would be able to like email this person or whatever and say, hey, I want to stay here for that amount of time. This is what it's going to cost me. Yeah, is that okay, or can I negotiate a better deal or whatever? That is what Airbnb does. In groups, so groups, get yourself in groups of 2 or 3. Honestly, I don't care. It could be 4. Don't work alone. Work together, but probably 2. Create a database schema or model everything that you need to know. I know I erased it because we're going to put it up there. Everything that you might need to know in order to implement a system like this. You've got listings, you've got apartments, there's pictures, you need to make sure people can email. What kind of objects do you have? What kind of attributes do those objects are there? and then what kind of relationships between those objects are there. And there might be some subtle ones in there that aren't immediately apparent, such as a reservation. A reservation is not a physical thing that exists anywhere. It's a conception. It's an agreement between two people that gets stored, in a database. That's all it is. But you need to model a reservation, right? So think about this. Figure out what kind of objects, attributes, and relations you need, and work on that. We'll take however long it takes, 15, 20 minutes. Talk, chat, be loud, get up, move around. I don't care. This should be enjoyable. But I want you to like the process of having them, think through this stuff. So. Yeah, get together, grab some food. Feel free. This should be comfortable and this should be fun. So, and really think through it. Like, go for that detail. Like, what's important here? So.
Is there what? I don't think so, no. It's just cloudy. We do not.
So what?
So we would say. I keep making space for you. You keep coming.
I've been sitting here like an hour.
And
So,
You have to print that the customer needs to print for the person client. You select and use the type of print. Availability.
I don't think the unit as much as just price. So price would take care of that, because if it's, depending on the price, it's going to be easier.
Is it?
Not necessarily. I mean,
Is it just what the market will bear? It could be a function
because
of.
that could be based on location.
That's right, right. Okay.
We're just trying to
We're just
determine our
New York.
That's all I was saying.
That's right.
Like,
No,
sometimes
like we're looking for. I'm looking for that
everybody.
Right.
Names of objects, their attributes,
Some kind
and
of really generic user and not another type.
Yeah, so basically a user list.
Well, that would be guess.
It's some sort
I
of.
mean, like someone could be, like out, but they could also be a guest. Say, base thing was like a user account. And that would contain information. They could maybe link to two separate accounts for that person. Like, if you want to call it a red team or a green team, but they would still have that base thing that's like their email address, password, stuff like that. And then you have the other major thing is the properties, right?
Yeah.
I'm just thinking out
So
loud.
where they want, the property, that's definitely it. So the different choices to choose from within the parameters that the customer is already support.
So these, that would just be a huge list of attributes.
That actually has
So
like
there
in New
needs
York.
to be some kind of like, so I guess I'm thinking like you have people and they could have person. You're saying like a property has to have like all the attributes, including the date range, right? That is a problem. It seems like we would need something in between those two. That it's just some object that. I don't know. Maybe you should put those in attributes.
Between, right? So the date range, I mean, where you're going is going to determine what's available. I mean, the date range is going to determine what's available.
You want some? But those are all attributes of the property. I think it's like when it's available. Like that property could actually have like a one-to-many relationship to like dates, or like times that it's available, and those could even have a separate price for each time. But it's still like your main thing.
Yeah, those are the attributes.
We should probably start.
Well, it can be a customer or the rental.
Anyone who creates an account.
Yeah.
Figure that out.
They're like orange, and then they walk away. And then other people like red. That's so awesome. That's
There's probably a lot less.
yeah, well, my product is
So we don't.
First few months of preschool.
Royal Blue. You guys want to make two different kinds of users, or you just want to have all the
I also like
for
mine.
one kind of user?
No, I think it's.
I'm not a Brody. No, I'm not. But I don't like it anymore. I haven't watched that.
This is my first class. I really enjoyed it. I understand my professor. Trying to understand anything he said. It's very complicated. And they went just very deep. Instead of covering the basics.
I don't remember what I thought.
We use that.
Character voices or whatever.
Okay. And then properties.
Well, so your property would be a location and
Reservation.
Property would definitely have.
Yeah,
Price, I think, is
super intense.
a one-to-many relationship. I don't know what you call it, but it's like available for days.
Yeah.
Because those could be
Seasonal.
discontinuous
Yeah.
days. You know what I mean? It could be like, we'd have one this weekend, and a month
Our powers
a
combined.
whole week. And you're not going to be able to, you'll have to have a separate price.
Mhm. But you also put in this
Should we be worried about,
location,
like,
you
getting
have
really
to have
specific
the
with their
having separate.
No, I think more text, number, stuff like that.
I'm trying to think more like.
I have like those listings.
Well, you have, I mean, if you
Location
have
is
a
not
group
an
of
actual-
guys going
So,
in for
you need to-
a weekend vacancy, and you got 8 guys,
So this, yeah.
So it's
they count, maybe.
Sure.
Okay, so,
But I mean, they have it set really
If it were
place
embedded
where, like, okay, if I'm one guy, I'm assuming I'm going to get whereas if I'm if there's 10 people, then there's.
well, they might be charging per person.
It can be available.
Yeah, I know that.
You might even want to get a different price on different times. Maybe there's, maybe you know WWDC is that week. If you have parts right here, you know, you can charge cars.
Yeah, exactly.
Just like that. So in other words, there's going to be people like, they can't find a place.
Right.
And they're willing to pay like just about any price to be downtown.
There's some kind of thing in Hawaii when I was there that
It can
and if it was during a certain period, you were not allowed to stay less than 1 day. You had to stay 3 days.
Where Airbnb was.
No, just a private Hawaii that we
But if
it's during a certain time, they require you to stay a certain amount of time. Money's gonna be.
Yeah, so what should we call that option? Like availability or something?
Yeah, we're not overly.
Your
I mean, it's like
availability.
you can only have one day.
$100 you can sell wherever.
So you're saying here, put a date, you're saying the most you can do is like a date. And I'm saying that you could have like a discrete object where when they stick with your calendar, you say 1 day or like.
So, okay, you're saying.
That would have its own.
Whether that's time.
Wouldn't you have your own date option?
I think there should be, there's an object, there's a one-to-many relationship. One property will have, you can have multiple prices. I don't know what it's called. Yeah, like different, well, just different days. So yeah, different days. I would think, I've never used it. I would think that you. They would have to specify when it's available.
Well, you could use it. It's like, I'm guessing that money as a rental.
Oh, well.
You would get that list your
Well, so you can either
We can do it this way, it's just that it will always have to be a continuous day. It would have to be from this day to this day.
I don't
And
think
that's it.
this.
And then you have to list it.
But I say, like if you're doing it on that sectional, different, more days. So I think that the day would not go. It would have to be a full.
Maybe, yeah.
I don't know if you would call it game.
Some of
They
it.
call it property. I don't know what you would call it.
Attribute.
URL.
Well,
Or availability.
All in one file.
Because they would list what dates.
For a renting period or something like that. That's all you need.
yeah, I think.
Yeah.
Okay.
And that's really just in the background. The user would never be aware of
So,
that.
And then within that, you
Yeah.
would specify a special date.
You would have dates, and then you would have times. You would have a start date and you would just have dates. Dates and.
Because also you would have to, you maybe want to put special instructions on certain things.
So like a.
Maybe, but that may go in a different level, because like we have our user. Otherwise, this is like, this. So there's one of these, too many of these.
Right.
And it could be a range that's probably better kind of a range. So you would say like,
Let's just put this like.
and then
What do you mean? Date period?
just two different things. So we have a big
It's really
we're getting caught up on the details. We gotta get more objects made. So if we have our users, and then they're going to be able to look at properties based on these and these.
Yeah.
Like attributes, but they'll also have to have like I don't know how it does it. Like what is the like when you click on a property, you say immediately print it.
Yeah.
What it does is it.
Can you say it's interesting?
I think so.
So there would have to be some kind of object.
Yeah, I think you can even check that.
We should also put images here.
Well, that, yeah, I was kind of taking that for granted.
Yeah, I forgot about it until I saw the webpage.
There's something where you can actually bucket it. Say, I might want to bucket it.
So that's the wish list.
Yeah, booking, reservation.
Yeah.
So you need another.
So, this is like my half
That's per month.
Oh, that's not bad at all.
Special tariffs?
It's not here.
Yeah, that's $7,000.
I found one
checked
for like
this out
50 bucks.
a long time ago. I find it-
What?
I was wondering-
I don't care, I mean, come on. Yeah, I mean.
I'm just kidding. Yeah. That is surprisingly inexpensive.
So
Okay,
you
we gotta
contact
connect
that computer.
All right. So,
this is what my.
We need to think about how you provide those things.
this is the rentee. And users are looking for a place. This is the user who is supplying.
So they have a certain idea.
So this has actually some relevance.
Yeah.
So this
Seems like it's no sense. Like, okay,
Whatever they're, yeah.
Well,
account holder next to the booking.
but this is
And they could
the.
have multiple bookings. Or is that the purpose of a wish list?
I think the same, yeah. So they can only book one.
Okay.
Is there applications
And do the
smart
same
enough
arrow
to
to
get?
this, and do two.
Will the application let you drink free beverages for free?
No.
For one guest? For one
If
guest,
the
but
date,
to
well, yeah,
the
you're talking about.
I don't know.
So this is the wish list we have had.
Well, we wanted two. Yeah, when I went on a trip.
Yeah, you can have.
Oh, I'm sorry.
Well, maybe they just need one. Either way is fine. It's an arbitrary. It's arbitrary. When we decide. Then so people who are renting.
This is the rent for.
Right, they're going to have properties. Right, there's going to be action going from here to yeah, they could have multiple properties, right? Some people do this.
These are like the big pieces. I don't know.
Technically not. It's legal in most
Like I can't
states,
wrap my mind.
right?
Somebody got like background, there's no little punk guys.
Yeah, sure, yeah. People live in high rent areas. I'm sure it's just
available.
I know, but I'm not living, you know,
So that could be booking.
So that, yeah, that's.
With the booking list and property, or property.
So the renter owns the property.
Enabling
This would be where this would be.
They, first renter, booking, they own a wish list. Those are too many.
The renter would be the one,
Right?
so like, this is actually
One property.
yeah.
Yeah, I keep thinking like you
Right, but then this, that connects there.
No, this goes here.
It's not just
And
the
this
tree.
goes here. Because they have to get the property. So it should be, this one goes to here.
But again, if you have a special price there, like if it's less few.
Or would you, well, hang on, maybe it's the other
Maybe we
way.
can just scratch this and make it a lot easier.
Or you go to,
I mean, but yeah.
you go to the date, and the date is the property's available.
10 times more efficient.
Right.
Yeah, but I think you'd have to, you would probably drill it off. I don't know.
Yeah, this was just something special in addition to the property.
So you've got a date right here, so the user will put in the availability of date here. Right. And this is behind the scenes, this shows that the date was in here, that the user will put in. And that will bring up what's available.
Right.
So he's reaching in here.
This is price.
It allows me,
What are you calling these things? Boxes?
I could never come up with a name.
But just a generic name.
Availability of some kind.
But the boxes each have.
Oh, I forgot the word. I was looking at that. Right above attributes. No, it's higher level attributes. I want to learn. I mean, he used some other word.
And maybe we'll
Right.
keep doing this, you know.
Relationships, identifiers, that's about
These are the
selection.
relationships.
Yeah, there we go.
So, yeah, but I think that that's a nice little subtle thing. Working on the scenes, just so that we can have prices, so you can just come down what the data is.
But they would have to put in the date here. Date 1 and date 2.
and I'm going to start this.
Right.
So how would you start?
So start and end date. You can have a little
But like,
thing of prices that you want to pay,
Yeah,
or not.
yeah, I mean, it's on their website, they have.
like if you read this,
Because I wonder if it's like.
And here's, you just have their information. And so you have to have the login ID, login,
Oh, right here.
and their credit card.
Yeah, well, it's like, so not that it needs to be in SQL or in Mongo format, but then that would be something to consider further.
Right.
When you have
Yeah,
tables,
yeah, if you're as big as
that
they're
is
going
going
to
to
be.
be the focus now. Most
Oh,
of the yeah, things
Otherwise, you might just throw the data away.
like one of them.
Whatever.
Well, you have to.
What?
Legal,
Oh.
most businesses can't.
Credit card debt.
Yes.
You're gonna do this, it's really, I'm gonna try it out.
They're a small thing, and you just like PayPal have them hold the credit card information, right? Use it as an interface,
So this price range.
right?
Strikes.
Right? There you do it too.
But I'm contradicting.
Yeah.
If you have actually something
That's the common
Older.
$0. See if they take it.
So then these pop up. So yeah, so we have the price. For
yeah. I separated.
Is it bolted?
Yeah.
Crash somewhere?
Yeah.
I can crash there for free.
Nice.
You know someone?
Yeah.
This gives me an idea though. Is it cool, bro?
He has a hell of a house.
If you were
All
See you. I went to your house. Anyway.
That's fun.
I mean, I was.
Look at that, you get that whole house.
It looks like his house.
All right, now, here.
We're getting sidetracked.
I mean, that would be really cool. I mean, it'd be like, if you want to decide if you want to buy a house or something, you could like rent somebody's house for their week.
So you look at this. You get
No,
just
I don't like
this. Check yes. The amount.
I mean, I wouldn't say it's perfect, that's pretty optimistic.
Airbus, that's Airbus, right? So you have their if they're setting it to fly. You might have this, but you still have their provider.
But that's all part of it's all ultimately part of
There's a service fee that they charge on the basis of how much
Right.
percentage.
I can't really. You guys really try to model out, but we could just go now. I don't know. Yeah.
Are we on the right track?
I mean, it's some rendered amount though. Like, you don't want to store like space on board higher, but like anything. If you can take two values out of the database and then get that other value, like doing some math derived, you don't want to store the rest of it. Yeah. So I think
It's
I'm sure that's.
calculated to show what it is.
I'm guessing. I don't know if
Yes,
this
and
is
then you hold this stuff.
It's probably
It looks kind of. So they just get coincidence.
and once they hit complete or good, then that information comes. So you'd have to have those fields.
All right, let's
Good on objects.
let's get
Right here. You're still using that. So I'm actually using ZSH. So that's,
So
there'd be
you'd need their
two,
name, address.
there'd be two, it'd be like that example where quantity, or there's two quantities, that can just.
Let's say, if you want to set it up, it's super simple. You just like, it makes it up here. So let me go back over.
Probably a lot of which is
This person doesn't like you can't.
I think that this could be that information, and
I
you
feel
could
like
have a field.
I feel like you might need like, you might need something as voice first, you know what I mean?
It's not a list of responsibility.
But you could have an identifier here that another field that says, are you looking for
It's the
this?
list.
Or- You don't have to have these. Almost.
You have to install
No, it's such a most people thing. The place.
So this is a good point.
Like,
Too tricky.
based on the value
For example,
in that field, it would supply another, it would go, take that if it else, and give somewhere
So
else.
then,
We also assume there's like there's probably a smaller barrier to entry.
They'll just not necessarily.
Maybe not.
For various, and
So you want calendar on both sides, so calendar.
I just mean for sign up, like how easy is it? It should probably be hard to listen.
actually, I don't think it's that hard. San Francisco.
well, just.
So you've got your list.
Like if you're signing up as a user, like those more, I just mean like you're more motivated. You probably expect. I mean, I see like value in that, and it seems like you would want to get two objectives either ends up these two, but you would want to ensure that there's like
too much of a side difference.
You know what I forgot about the food I did with that?
I hate to think about things.
People decide
Yeah.
so everybody has a justification person reviews. And I think they get an overall. I don't know if you can get stars or actual numeric representations. So that might be something that
And the property would have that
Yeah.
as well.
Well, they might have, what does it say? If it's not a problem?
Yeah, exactly. Yeah,
So it goes into
and
the
The type of place.
So,
And that's what I'm saying, you know, so if you're going to get separate properties based on people that have this folder of themes, right?
can you switch to any of these themes over here?
That's pretty
I just changed this one string.
Yeah.
And it was like,
There could be two
locations.
Oh, this is.
You just keep going down mirror.
So if you have, okay, so in here, you list in your place, because they don't even care. You don't need their address.
The
Person, they don't need their address.
It may be assumed that that is their one property.
They're getting-
Maybe that's the way they set it up. I don't know. It's just about
everything in the
people
list.
just have multiple accounts.
Or you haven't,
Yeah,
yeah.
that could be a minimization.
So it's more.
Maybe illegal
More
as well.
I, you know, of course, we rank this, and there's lots of more.
I'll call it DTV. So just for the show.
So you would have property time.
So that's what's like.
Oh, and that is like apartment, house.
Do it all in one table.
It's like a show.
So that was an element. So you have to search the entire table. I do
You have to put up their house for the mission.
I consider ID like that's a
Like their listings said that
maybe like 100 tags.
their money is good.
What's it?
Because everybody's saying it.
Your Airbnb.
Yeah, I keep calling it me too.
And then it's like my file.
Oh, I see.
$30.
Everything that has a tag onto this list.
Really?
It's almost like allowing.
So you don't have to remember all the damn tar
It's
it's
like a real
whatever's in
right?
That's everything. I was in right now.
Yeah, so your rent's outside the food. If you want to live in town, but you don't have a super deep or high paying job.
Or you just,
And maybe-
yeah, I mean,
or maybe you
I was
just want to
just
make
trying to
it
decide to move to New York.
Yeah.
How do you do it? So, I mean, I don't have any, I need to, I mean, I had the money, but I need to find a job. So I'm like, oh, you know, just, you need someone who's willing to help you, stay at their place for a period of time.
Okay. Let's wrap it up here. I'll give you another minute to finish up your conversations, or I guess we should say now since I interrupted and everybody's quiet and like staring at me. Let's talk about what we came up with for our, so that we can see if we're kind of wrapping our heads around this. So. You don't want to talk about it?
So let's
I guess
take
we
this.
could. It doesn't feel very complete.
That's okay. It shouldn't feel complete. I mean, people spend a year building a product, right?
Right. We got like too detailed at the start, and then
I wonder whose fault was that?
Mine, actually. It was
Okay.
a part of mine.
Well, let's start out broad. So throw out there what kind of objects are you guys modeling for this? So what do I need to keep track of in our database? What kind of tables or collections do we have?
You need properties, definitely.
So what do you mean by properties?
Like an actual physical location.
Okay.
Some kind of real estate.
So this is like a listing?
Not necessarily, but like on ours, it wasn't. It was a property, and then it could have a specific listing.
Okay.
multiple listings attached to that.
So property being place where it's,
Address?
Like an address?
and then listing being the actual physical property itself.
Okay, so like you could have an apartment complex would be a property, and listings would be number of apartments in it, or
I'm thinking like date ranges. Like so,
Well,
if you go through and say
actually-
it's available during these times,
Okay,
and
that would
it
be
may
a
not be
That was a
contiguous.
separate.
Yeah, that's a separate. And he represented.
Okay, right. So property is the thing, and then listing is it's actually okay. I just listed this property,
Right.
and here are the date ranges. Okay, what else we got? So what else? What other kinds of stuff are we modeling here? Yeah. Okay, so we're gonna have users. A user can have multiple properties. Sure, makes sense, right? Okay, what else we got? What kind of
reservations, which would flow off the other side of users, and you made it so that a user can have listings and reservations.
okay? Probably more than one, right?
Yeah.
So I use those double arrows for one to many, right? And then a reservation has to make reference to listing, obviously, yeah. Sweet. So, but it probably only makes reference to one, right? Okay. What else we got?
Wish list.
Wish lists. That's what do you got back there?
Under listing, the location of listing.
Okay, so attributes. Let's talk about attributes real quick. So what does a listing have? Okay, so what is a location, for one? Location is not a simple attribute.
The location is city, country, state, zip code.
Okay, so are you storing that in a separate table, or is that under the listing? But then it wouldn't really be under the listing, it would be under the property, right? Or the location, or the property. So really, I mean, it depends on if you separated these out. Probably I could see you want to do that. So an attribute here would be location, but location is really a bunch of things, right? And make sure you break those out so you're clear
So
about
would
that.
that be its own table?
Depends. I don't know.
You have limited countries and limited cities, so maybe you store that in the table because you wouldn't want to store a bunch of duplicates.
I think that's, honestly, I don't know what the right answer is. I think that's a design decision. Yeah. I think you could do it either way. So you could have a locations table, and a listing or a property has one location, right? Probably. And location is city, state, zip, all those things that we looked at before. Or you could actually have this stuff on this guy. So, okay. What else? Yeah.
Under the property, cost, rooms, smoking.
Okay. So let's break some of those up because let's make the difference between property and listing explicit. So will a property probably has like, so what were they again?
Cost, how many rooms, and smoking.
Cost, number of rooms, smoking. Okay, so I could see how smoking and number of rooms might be under property, but cost might go under listing because you might change the cost for each listing.
But can you
Or even
simplify that by just
Well, reservation is going the other direction, though,
Yeah.
right? So
couldn't you? But users would determine number of rooms.
Okay,
So
that's right. Well, that's okay though. I mean, somebody's entering all this data, yeah. So, where would you think number of rooms would go instead?
I think it would go under.
under property itself. Yeah.
Yeah, sorry. That's what I mean here. These guys are under here. So,
Yes, bed and bath.
so I just ran out of space. But yes, these are properties. Number of rooms and smoking are under properties.
Square footage.
So, square footage. Okay, sure.
Wireless.
Does it have Wi-Fi? Okay, sure.
Yeah, there was like an
Amenities.
yeah, I can't even say it.
Okay.
Amenities.
So
Amenities.
what's that? So we want to have pictures. Now, a picture itself is probably its own table. And a picture will have things like the file name, and then the title, and then a property or a listing, whichever way you're doing it. It could be either way, I suppose. But let's say property will probably have a number of pictures, right?
Yeah, because like.
What about availability date?
Where would that go?
Listing.
Probably under listing. So I put that under listing, availability. Okay. And explicitly, what is availability? Availability is not a simple attribute. Date, what is a date range?
Start and end date.
Start and end dates. That's like the granularity that you have to be thinking of, right? So an availability is not simple. We can't store a date range in the database. So we say start available and end available, right? Okay.
And users have like a display picture as well.
Okay. Yeah, so we'll put that under there because you can put data blobs. So we'll say profile pic. What else might a user have? That's an important one.
Payment info.
Name. Ooh, so payment info is almost certainly its own table. So this is like their bank account or PayPal information. And then it could be different depending on whether you're a user who is providing a listing or is a user who's acquiring a listing. Yeah. So you might have two different kinds of payment info. So, you know, there could be another table here. I'll just call it payment info 2.
We were thinking it might be easier just to have like users and then have it point to two different kinds of users because you might see some more disparities. Like,
yeah, you could see that. So you could have like renters and rentees or whatever, right?
And you need the login information.
So you need login information. What does that consist of?
Username, password.
Okay, so username. You're going to see this more and more. Sites
Security questions.
aren't using username, but they're using email instead.
Yeah.
Sometimes they won't do it. Then you'll have password, but you won't actually store the password in the database.
Yeah, that's good.
What do you store in the database instead?
Hash. Like,
A hash of what? The password. So we call it the password hash or the encrypted hash. And what is known as a salt, which is often combined with the password that the user provides to make the hash even more unique. So you take the password, you add the salt to it, it's a random string of characters, and then you hash that combination of things using bcrypt or whatever, and then it gives you this end result. But you need to keep the salt. Then when the user logs in, you get the password that they give you, get the salt for that user's ID or whatever, combine it with the password again, encrypt it again, and see if it matches the hash that you have in the database. Right? And that's one way. You can't undo a hash, typically. Although I suppose if you have enough computing machinery, you can.
Security questions.
So security questions, and those might be its own separate table as well, right? Because you might have like 5 different security questions. What's your favorite, dog or whatever? And then users will refer to security questions.
Yours.
Okay, and what does a reservation involve?
We spent a good amount of time dealing with dates, so this is tied in with that. So a reservation would have dates in terms of dates booked, and then a listing would have dates as well.
In terms of dates available, right?
Already have it here.
Yeah, so that's 2 valid, yeah, good subtlety to be aware of. So we have a booked start and a booked end, and those will almost probably certainly, probably more often than not match up, right?
Right. Yeah.
So I need 7 days of the 10 that you have available. Okay. What's on the wish list?
Apparently I have one.
Properties.
Or is it listed?
It's properties,
Properties.
and it would be one to many.
One to many. So right. So many properties. Okay. So let's.
Well,
play that
it
in
says
that
my
version.
wish list.
Okay. So well, it's one to many to properties, right? So this is playing over here to properties, one to many, and then users have many wish lists. Is that what you're saying?
I don't think they should have many.
Just one?
One wish list with many properties.
Right. Okay. That's why. I mean, either way, right? So you get to decide. You're the application designer. Yeah. It's not. This is the important thing. This is one of the amazing things about building your own stuff. There's no right way to do it. There's the way that you've identified that your market wants or your customers want or that you think is right.
Why would you want the wish list to contain properties on listings? If the listings would be what determines.
That's true.
I would think it would need
maybe,
listings.
but it's so far in the future, those listings might expire at some point. And then you say,
Right.
like,
Listings no longer exist,
Yeah.
so listings come and go, but properties stay. Right.
Right.
Yep. You see that? A good question. A nice bit of subtlety. And so this is good, right? So good. So you guys seem like you have a grasp on the kinds of things that we need to think about. The further question is, how do we actually implement this in a database? And that's a second question that we will consider as we look more at databases on Monday. But I come to you and say, okay, let's build an application. And imagine this is a client that's coming to you. The client says, I want to build an application that lets people list their properties and other people rent them for a time period. And you're like, okay, give me a couple of specifications. And they give you a paragraph of information. And they're like, and so you can just like build that in 2 weeks, right? And then you go and start working on this thing, and this thing blows up in complexity really fast. And your client's like, what? This can't be that hard. And you're like, no, it is that hard. Yeah, and then because then you got to implement all of this stuff. So I think there's often a misconception that making these things is easy. We have the technology to implement what we want to implement easily. That's what we're learning in this class. Coming up with the idea itself and understanding all the requirements is a whole nother step in that process. You're going to get really good at implementation. This is something else. Yeah, this is a different kind of problem solving and brainstorming. That is harder for sure. And there's not easy tools for this. There's like, what's your best practice? It's what your customer wants. I don't know. What does your customer want? There's again like no right answer, right? Sweet. Yeah. So that's data modeling. Next week, we ran a little bit over. Next week, let me put this up here. We are going to look at MongoDB. I cannot remember if it was part of your preparation for the application to this class to install MongoDB. Did you guys do that? Install MongoDB. Homework assignment. Before you come to class, install MongoDB. If you are using Homebrew on the Mac, brew install MongoDB or whatever it is. PC or you're not using Homebrew, there's a download thing over here. It's really easy to install. It's just as easy to install as Node. And we're going to learn about using MongoDB and then ultimately incorporating it into our application, our Node application, next week. But part of your homework assignment is getting this. Other part, do check out these resources that I mentioned at the top of our page for today. So especially data modeling and CRUD. Yeah, you want to be familiar with those. And then keep working on the assignment that we had from Monday, getting views and rendering with the dummy data that I got you. Feel free to extend that if you already got that done. Start working on views for the comments, because ultimately this is the product that we're building, right? We're going to build a blog application. We have posts. We're going to have comments. Hopefully we get to users, and then we're going to tie it all into a database. But at this point, we know how to use Node. We know how to use views. We know how to use HTML and CSS. We are moving to the final piece of this puzzle, which is databases. So, okay, cool. Thanks, guys.
No idea.
Phil,
Yeah.
what's the Wi-Fi?